Okay, I'll let you read this problem in its entirety. But we've got newspaper ads, we've got radio ads that cost different amounts, and we've got potential customers that can be reached by each type of ad. Uh, we've got these restrictions on the number of ads. For newspapers, the most you can have is 19. For radio, 28. And this is the objective function right here that we want to maximize. What combination of N and R will give us the most exposure? Okay. So one way to do it is based on customers per dollar. So if the most people you can reach for newspaper ads is 6,550 and each ad costs $130, that means you're getting 50 customers, a little over 50 customers for every dollar that you spend. And if you do it with radio, you're only reaching 24 customers for every dollar. So this is the quantity that we want to maximize. So we want to spend as much as we can on newspapers, but the most you can spend is 19. The most ad you can have is 19. Each ad costs $130. So you're going to use up $2,470 out of the $4,910 you have available. So if we subtract that, that's the amount that's left over, $2,440. But if we divide by 310, that's the number of radio ads that you can have to maximize this number of potential customers. It looks like with that combination, 19 newspaper and 7 radio ads, although I didn't round that off, you can reach 183,800 plus customers. Now that's one way to do it. Another way to do it is with linear programming. Okay, so that requires you to graph. So this region right here is your feasible region. We've got X less than 19, that's this area. Y less than 28, that gives us this rectangle right here. But then we add on the fact that the most you can spend is this, where do I have that? Oh, right here, $4,910. That's what this green line is right here. And we want to be below that line. So that's what this region is right here. And linear programming says that if you pick any X and Y in this feasible region and plug it into the objective function, you're going to get the exposure. But linear programming theorem proves that the X and Y in the feasible region has to be at one of the vertices. And that's what this black line right here is. It's the objective function. This guy right here, written in a slightly different form. You can see that that line will get its highest Y value up here at this vertex. But you can figure that out by plugging in those numbers into the objective function. And here's that row right here. 19 for newspaper, radio ads, 183,000. If you try to do 19 and 8, you go over your 4910. So that's why this row can't really count. The same for 19.9. If you do 10 newspaper and 11 radio, you don't get your maximum amount. Okay, so that's how you do it with linear programming. Okay, there you go. Hope that helped. If you have any questions, post a comment.